Hi, in this video, I'm going to show you how to find domain in range of different functions, and I will show you 8 different examples from linear function to quadratic, then square root, exponential function, logarithmic, trigonometric, and finally rational function. But before we start, let's make sure that we all understand what domain and range are. Imagine you have a function and its graph goes from point A to point B. Now, let's call the x-coordinate of point A, A, and the x-coordinate of point B, B. And the y-coordinates are going to be C and D, respectively. Now, you can probably see that the function doesn't go to the left of A on x-axis, and it doesn't go to the right of B on x-axis as well. So that means the x values can only be from A to B. And that's what we call the domain of the function. So all the values of x that function can take as its input. This is called domain. Very similarly, the function doesn't go above D on y-axis and it doesn't go below C on y-axis. So it's only from C to D. And that's what we call the range of the function. So the range is all the output values of the function that it can produce. Now, how do you find the domain? As you can probably remember, domain is all the input values of the function. So what can restrict you from putting some number in a function? Well, there are a few things. For example, there could be a square root. Can we take a square root of a negative number? No. So in that case, whenever you have the square root, you have to make sure that the expression under the square root is bigger or equal to 0. Now, the next thing could be a logarithmic function. We cannot take a log of a negative number or the log of 0. So whenever you have a log function, you have to make sure that the expression in a log function is bigger than 0. And the third thing that can possibly restrict the domain is dividing by 0. Okay, so we never divide by 0. So whenever we have a rational function, make sure that the denominator is never 0. Now let's have a look at different examples. The first one is going to be the linear function. F of x equals to 4x plus 1. Now, first of all, let's try to think about the domain. Are there any restrictions on the input value? No, we're not dividing by anything. We're not taking the square root. We're not having the square root. So there are no restrictions. That means x could be any number. And we can write it in several ways. So the first one would be x is any real number, which can be written like this, or you can write it as x is from minus infinity to positive infinity. So that is going to be our domain. Now, what about the range? To find the range, the easiest thing to do is to sketch the function. For x plus 1 is the linear function. So the graph of this is going to be a straight line. Let's substitute x equals to 0. Y is going to be 1. And it goes like this. Also, the output value could be any number. So the range would be y is any real number. Or you could write it like this, from minus infinity to positive infinity. Okay, second example. Quadratic. Y equals to x squared minus 4x plus 1. First of all, let's try to think about the domain. Are there any restrictions on the input values? Again, no, we're not dividing, we're not taking a square root, we're not taking a log. So domain would be x is any real number, or we could write it as x is from minus infinity to plus infinity. What about the range? We have to draw a sketch again. Quadratic function is going to look like a U shape. And to sketch it, let's find first of all the turning point. So the x-coordinate of a turning point of quadratic function is minus b over 2a. Or you can use differentiation in order to find it. I'll just use minus b over 2a. Let's substitute all the numbers in there. So b is minus 4. A, the number in front of x squared, is 1. So all in all, we have minus 4 divided by 2, and the minus in front, which gives us positive 2. Now let's find the y-coordinate of the vertex. Substitute 2 in the function. And we get 4 minus 8 plus 1 equals 2 minus 3. And here goes the sketch. Let's draw y and x axis. x2, y equals to minus 3, so here's the point. Okay, and it's a U shape. It opens up like that. Now let's look at our possible values of y that function can take. So you see that the function doesn't go below this turning point. So everything above minus 3 is going to be the range of the function. So the range is y is bigger or equal than negative 3. Or you could write it as y is from minus 3. Oh, should be the square bracket because we're including negative 3 to plus infinity. Let's move on to the next example. This time it's going to be square root. Y equals to square root of 4 minus x. Now remember, we cannot take the square root of a negative number, so that means 4 minus x must be bigger or equal than 0. Let's solve this inequality. Move 4 to the other side, then divide by minus 1. Don't forget to flip the inequality sign when you're multiplying or dividing by a negative number. So we get x is less or equal than 4. And this is going to be our domain. What about the range? Again, we have to sketch the function. Right, our input values are less or equal than 4. Let's draw number 4 on x-axis. And let's substitute some numbers smaller than 4. Let's say 3. 4 minus 3 is going to be 1. Square root of 1 is 1. Let's substitute 0. Square root of 4 is going to be 2. And so on and so forth. So that's how the function looks like. It keeps increasing. However, it never goes below 0 on y-axis. So this is going to be our range. Y is bigger or equal than 0. Next example. Again, square root. Square root of 1 minus x squared. Again, we have the square root, and the expression under the square root cannot be negative. So that means y minus x squared must be bigger or equal than 0. Now this time we have the quadratic inequality, and in order to solve it, we'll have to sketch the quadratic function. All we're interested in is only intersection with x-axis, which happen when 1 minus x squared equal to 0. And now let's solve the equation. X squared equals to 1. Take the square root, and don't forget that it has two values, plus or minus 1. A quick sketch, minus 1 and 1. And then look, the number in front of x squared is negative. So that means our quadratic function opens downward, like this. Now, which values of x are we interested in? Look at the inequality sign. We want 1 minus x squared to be bigger than 0. So it must be above x-axis. That means x is in between minus 1 and 1. And this is our domain. X is from minus 1, including minus 1, to positive 1, again including 1. Or if you're using the interval notation, you can write it as x belongs to the interval from minus 1 to positive 1. Okay, now let's draw the sketch of this graph to find the range of the function. Now we know that x values should be in between minus 1 and 1. When we substitute 1 or minus 1, we will get 0. Let's substitute x equals to 0, we get 1. And then when x goes from 0 to 1, our output values are going to decrease. So the graph is going to look like that. And the same happens to the left of 0. So this is our sketch. And we can see that the output of this function is quite limited this time. It's from 0 to 1. So y is from 0 to 1, or we can write it as this. Y is from 0 to 1. Let's move on to the next example. This time it's going to be exponential function, or the power function, 2 to the power of x. Can you raise 2 to any power? Negative, positive, 0? Yes, why not? So that means the domain of the function is going to be any real number. What about the range? Again, we need a sketch. Let's raise 2 to the power of 0, and we get 1. And as you increase the power, the output is going to be bigger and bigger and bigger. But if you go to the left of 0, let's say 2 to the power of negative 1 is going to be 1 over 2. So your output is getting smaller and smaller and smaller. However, whatever number you take for x, you can never go below 0. Right? So 2 to any power is never 0. That means our range is going to be from 0 to infinity. But there's one thing to be careful about. 2 to any power is never 0. So our range is going to be y is bigger and not or equal than 0. And if you're using the interval notation, you can write it as y belongs to 0 to infinity. Next example. Logarithmic function. Y equals to natural log of x plus 1. And let's start with the domain. Can the input be any number? No, not this time, because the expression in a logarithmic function should be bigger than 0. So that means x is bigger than -1. That's our domain. Time for a sketch. Let's put -1. Okay, so x is bigger than -1. That means we never go to the left of -1. And the graph looks like that. If you studied inverse functions, you can probably notice some similarities with the previous example, 2 to the power of x and log x, right? Because a logarithmic function is the inverse of an exponential. So the graph of the logarithmic function is going to be the reflection on the line y equals to x of the graph of the exponent. Okay, now time for the range. As x goes closer and closer to -1, we can see that the values of y are going to be smaller and smaller and smaller and smaller. And y keeps increasing as x goes to positive infinity. And there is nothing to limit the value of y. So our range is going to be y is in between minus infinity and plus infinity. Or you could write it as y is any real number. Next question. Let's say 7. Now it's time for some trigonometry. Y equals to 4 sine 2x. Now, start with the domain. Are there any restrictions for input values of sine? Well, you can take sine of any number, so no, not this time. X is any real number. What about the range? Yes, of course, range is going to be limited because the graph of sine x is bounded between -1 and 1. Now, let's try to think about the graph of 4 sine 2x. Starting with the graph of sine x. Now, you probably know that the graph of sine looks like a wave from -1 to 1 on y-axis. So sine x is in between -1 and 1. Now, what happens if we put 2 next to x? The graph is going to shrink on x-axis twice, 2 times. Horizontal shrink, but it's not going to change the output values. So sine to x is still in between -1 and 1. Now, what does the 4 do? See, you're multiplying every output value by 4, so your graph is going to be 4 times larger than it used to be. So the graph of 4 sine to x is going to be in between -4 and 4. So it's going to be stretch on y-axis. Now, technically, we're ready to state the domain from -4 to 4, but still, let's stay consistent and draw the graph of 4 sine to x. Let's put all the key points, pi over 2, pi, minus pi over 2, and minus pi. So the graph of 4 sine to x still goes through the point 0, 0. And now the maximum value, instead of being at pi over 2, is going to be pi over 4. Remember, our graph shrinks horizontally 2 times. And it's going to look like this. From -4 to 4. Or we can write it as y belongs to -4, 4. Okay, next question. Rational function y equals 4 over x plus 5. Starting with the domain. Are there any restrictions on the input values? Yes, you cannot divide by 0, so it means x plus 5 cannot be equal to 0, or x is not equal to -5. We can write it as, well, x not equal to -5, or we can write it as x is from -infinity to -5. I'm going to use the round bracket to show that I'm not including -5 into my domain. Or you could write it as x is any real number except -5. So 3 ways to write it. Now, what about the range? Again, sketch. Now, x cannot be equal to -5. And it's very useful to remember how the graph of a rational function looks like. Let's sketch somewhere on the side y equals to 1 over x. So it looks like this. Has 2 parts. And it's never going to cross x equals to 0, because we cannot divide by 0. Now, whenever we have y equals to 4 over x plus 5, it's going to look very similarly. But only this time, the break, or the asymptote is going to move to x equals to -5. So the graph is going to look like this. Now, when you look at this graph and you want to state the range of the function, it's very easy to make this mistake and say that y is from -infinity to +infinity, because it kind of looks like this. However, don't forget that the y value is never equal to 0. So we'll say that the range is y belongs to -infinity to 0, union 0 to positive infinity, or we could write it as y is not equal to 0, or if you prefer this way, y is any real number except 0. And that was our last example for today. I hope it was useful, and just a reminder how to find a domain and the range. So for the domain, look at the possible input values of the function. What can possibly limit your domain is the square root, log, or dividing by 0. And for the output values, that's going to be the range, you just have to sketch the graph of the function. It takes some practice and it takes some time, but it's really worth it if you're studying calculus or just math in general. Okay, so that's it for today. Thanks for watching. Bye.